Hello guys, today I'll be explaining the limits of function using some examples. Particularly, I'll start with the basics. So in this particular video, I'm not going to bore you with how Cauchy met sequence and how sequence met Cauchy. So this video is basically calculus. So if you're not subscribed to my channel, I'm saying click on that subscription button for you to get great content like this and more. So let's jump right into it. In calculus, the limit of a function describes what value. The limit of a function describes what value the function approaches to as the value of x gets closer and closer to some numbers. So this is how limit is written. We have the lim of the function f of x as the value of x gets closer and closer to some values. So like I said, I am not going to bore you with plenty definition of how epsilon goes to Cauchy and all that. So now if we have this particular question, right, let's say we have a question that says we have a limit f, the function f of x is equal to what, 2x, right, and we're asked to find what the limit as x approaches, say, 3, right? So how do we just solve using the idea of what limit? So for limit, right, so we have the lim, let me rewrite it. We have the lim x as it approaches 3 of what, 2x, which is a function, is equal to, now as x approaches 3, right, we know that this function gets closer and closer, right, to a particular number that we don't know. So all we just need to do is we just say 2 multiply by that value x, that value of x, which is what, 3, and 2 times 3 gives us 6. So as s gets closer and closer to 3, right, we get the limit of what, 6. That's what it means. We get the limit 6. So with this particular physical knowledge, I'm going to solve other examples. So if you have a question, you can just drop it in the comment section, and if this particular video makes sense to you, you can help me share with your other friends. So the question is, as x approaches 1, right, we're asked to find the limit of this particular function, x squared minus 1 all divided by x. Now if you look at this particular function very well, right, look at this particular function very well. Okay, let me write solution, and I'm going to write it in terms of limit. So we have the limit as x approaches 1. Now I'll put this function in the bracket of x squared minus 1 all divided by x minus 1, close bracket. Now if we fix 1 in this particular function, right, if we're putting 1 in this particular function, how is it going to look like? So let's say we have x squared minus 1 all divided by x minus 1. So if I put a 1 here and square it, then 1 minus 1, at the denominator 1 minus 1 is already 0, right? So we have a 0 here. Now likewise, at the numerator 1 square is still 1, so we still have 1 minus 1, so everything is what, 0, which is wrong. It's completely wrong. So how then do we solve this particular question? Now if you look at the question very well, we can use different methods to solving the question. All right, now we can use factorization to solve this particular question, or we can use the L'Hopital, the almighty L'Hopital rule. So let's use factorization. So using factorization, we just need to factorize the numerator here, because that particular expression is a quadratic expression. That's x squared minus 1. So we can write it as a difference of 2 squares, right? Meaning that if I have my x squared and 1 square. Now 1 square is still 1, right? So that means in difference of 2 squares we have what, x minus 1 and x plus 1 for this particular expression. So I'll now take this particular expression I have here and in fix it in what, this limit. So it becomes the limit of x approaches what, 1 of, now instead of writing what I have initially, I'll just write my factorization. I have x minus 1 and x plus 1 all divided by what, x minus 1. So I'll put this one in bracket so you can see. So x minus 1 at the top, x minus 1 at the down. So I was eager, so that's why I just cleaned it. So we have this, right? So everything now is now equal to what, x plus 1, right? So now we can confidently fix the value of x, right? Since according to the limit, the value of x approaches what, 1. So when we fix it here, it becomes what, 1 plus 1, and 1 plus 1 is what, 2. So that is the answer to this particular question. So if you understood what I said, what I just did, right? I started by saying the expression at the top is a quadratic expression. This one at the top here is a quadratic expression. This expression here is a quadratic expression. So what we need to do is what, to factorize, because I'm using the idea of factorization for now. So in my next video, I'm going to use other methods like L'Hopital's rule and the rest to deal with such limits, and you see how beautiful it is to use other methods that are more simpler than using factorization method. So if you have a question to what I just did, or you have an observation, you just drop it. Thank you very much. Let's move to the next question. Beautiful. There's another beautiful question, and here in the number 2, right? Likewise, if we fix the value of x as minus 3, because the limit here is what, the limit here, the function is x squared minus 9 all divided by x plus 3 as x approaches minus 3. So if we fix minus 3 in the expression, right, what do we get? Look at the denominator. If I put a minus 3 here, I will get what, a 0. So it makes the entire expression 0, which is not correct. All right. So all the examples I'm dealing with here, I'm using the idea of what, difference of two squares. It's just to explain the basics of limit. I know there are other methods to solving limits that are more simpler than this, but I'm moving with a series, right? And it's a gradual process I'm going. So what do we do to this particular limit? We just factorize the numerator. So the numerator is what, x squared minus 9, right? So this implies we have what, x squared minus, now what do I square to get 9? I just have to square what, 3 squared gives me what, 9. So since 3 squared gives me 9, this in difference of two squares becomes what, x minus 3 and another x plus 3. So this is it. So what I'm going to do here is just fix my difference of two squares in the expression and just strike out. Then I'm done with my question. So my limit is this as x approaches what, minus 3 of, let me use a square bracket, put this one in the bracket. We have x minus 3 close bracket, we have x plus what, 3 close bracket, all divided by what, x plus 3, right? So we have this. Now since I have x plus 3 and x plus 3 at the numerator and x plus 3 at the denominator, what do? I just strike out x plus 3, strike out x plus 3, and finally I have x minus 3. All right, x minus 3. So if we fix the value of x that we have here, now this now becomes what, x is giving us what, minus 3. So we have minus 3 minus 3, and everything is equal to what, minus 6. So this is it. This is how beautiful this one is also. Let's move quickly to the next question. Question 3. This is question number 3, right? And the question says the limit as x approaches 9 of 2x minus 18 at the numerator divided by x the root of x minus 3. Now let's look at the denominator quickly. All right. Now, since we have a root of x here, and our x is what, 9, right? X approaches 9. So if I fix a 9 in this denominator, the root here, it becomes what, 3. The root of 9 is 3. So we know the root of 9 is what, 3, right? So if I fix that there, it gives me what? It gives me 3, which is not what I'm looking for. Which is not what I'm looking for. So what I'm going to do here is what, to factorize. So in factorization, I'm going to use a particular idea, right, to factorize the numerator. So I have 2x minus what, 18 as my numerator. Now this implies I have, now since there's a 2 here and there's an 18 here, that means I can factor out the 2. Now I have x minus 9. X minus 9. So that 2 times 9 gives me what, 18. Beautiful. Now since I have x minus 3 as my denominator, there's a way I want to transform my numerator so that it fits my denominator. Now this is it. Now instead of having just x minus 9, I'm going to transform that to what? The root of x minus 3. Now this goes with a square, and this also goes with a square, like this. Now you know that if I square this particular the root of x, I'm going to get x. Likewise, if I square this one, I'm going to get 9. So nothing changes here. So this now fits exactly the root of the difference of 2 squares. So in a square bracket, I put my difference of 2 squares. Open a bracket here, I have what? The root of x minus what? 3, close bracket. Then I have what? The root of x plus 3, close bracket. So this is my difference of 2 squares. So I now fix this particular difference of 2 squares in the expression at the top. So it becomes the name as x approaches what? 9 of what? Of the root of x minus 3, close bracket, and the root of x plus 3, close bracket, all divided by what? The root of x minus 3. So I close my square bracket. So if you look at it clearly, you discover that I have the root of x minus 3 at the top, and I also have the root of x minus 3 below. So I just strike out that 2, right? And we're left with the root of x plus 3. Beautiful. So since the limit says x approaches 9, right? So we now have, we just fix our 9 in this particular root. We have 9 plus 3. And 9 plus 3. So the root of 9 is what? 3. So we have 3 there. And this is what? 6. Now notice something, that at the top I have 2 here. So I didn't include the 2. So let me bring back my 2. It's 2 here. And 2 is supposed to be here. And likewise this part. And finally at this part we have a 2 here. Finally here also we have a 2. And at this part we have 2 following us. So finally we have 2 times 6, which is equal to 12. So the answer is 12. So thank you guys for watching. So I am going to drop one question here for you to try, and you tell me the answer. So this is the question. So you just try it and you drop your answers in the comment section. So see you guys in the next one. Now in the next video, I'll be explaining the rules of logarithm and be using other ideas in solving the questions. Thank you guys for watching.